Hello. What we're going to do today is we will work on an interrupt example that we will apply that to a C program that we will create on STM32CUBE IDE with where the interrupt is going to enable us to blink an LED at a push button. Okay, so that's what we're going to adjust from scratch. And the first thing that we have to do is open up CUBE IDE as we have done already here, and we create a new project. So file, new, STM32 project. We wait until it opens up a new project window so that I can type in my name for that new project. There's a target selector is being initialized. We choose our device to begin with as usual, so these are the usual steps. I'm just going to go over these very fast, so if you don't understand these, please refer back to my previous videos. So the first project name is my interrupt blink experiment. That's going to be a C program, and I just click finish here to start creating the project. It loads up the IOC screen for us to choose our device inputs and outputs. We wait until that is completed. Now we have our device opened up in front of us. What we just have to do is we just get in to this chip and we designate. We know that port A5 is our LED output, so just click that safely as an output device. So that's going to be a GPIO output. Next, we're going to go into PC13, and that's going to be our device that we're going to be having the push button inputs from. It's not going to be a simple input, it's just going to be a GPIO XI3 that's going to be defined as GPIO EXTI13. That's going to be associated with our interrupt. So that's going to be associated with our interrupt in the next sequence of operations that we're going to do over here. So I opened up my system core over here. You can check it out. That's the GPIO part. I just click on that, and as you see, I have two of my port pins are connected to either the output and the push button, and one of them is being the extern. I can name them differently. I can just name them as button for PC13 safely. I can do that, and for PA5 I can safely name that as my LED. So in the program it's already defined as within these aliases, so I can search them much better. Now what you have to do is, if you want to do debugging, of course you have to come back here and then click on sys, and you have to enable the debugger for the SYS. It's going to be a serial wire debugging process where your UART is going to be associated with the serial wire to your system. Click on NVIC and make sure that your EXTI line is an interrupt. You have to generate that 15 through 10 interrupt subroutine, so that subroutine is going to be added to our code in the end. So the code is going to be generated associated with that pin 13. Pin 13 is within this limit from 15 through 10, so an interrupt is going to be generated for that purpose. So I just have to click that point over here and make sure that an interrupt service routine ISR is going to be generated in my main code. So NVIC part is used for that purpose. Let me get back to my GPIO Make sure that I have EXTI line 15 through 10 interrupt is also enabled, as you see here. Okay, I have made sure that my device is set up. One more thing to do is PC13 is going to be set as an external interrupt mode with a rising edge trigger detection. Now I'm going to be seeking a falling edge. Since I push a button, I would like a 5 to 0 transition, from high to low transition. So I would make this rather a falling edge trigger detection over here at the bottom. So GPIO mode corresponds to external interrupt mode with falling edge trigger detection. I would rather have a pull up here, so make sure that I have BDD coming in when I'm not pushing anything on the button. So pull up is also quite useful in this case. So make sure that that's also pull up in your selections for PC13. So we're almost there. What we're gonna have to do, we have to generate the code if there's nothing else to do. One more thing, maybe what we can do is before we generate the code, we should have done that actually. We could have created an external also in the connectivity part. So I can associate the USAR, I can enable that, so I can have also an external being opened up, so I can have some information being broadcasted on my terminal using the Putty file, Putty program. Now I will also fire up Putty along with my code run, so I can track where the GPIO is actually triggering my system. I can have a feedback on the screen. So it's a good idea to do that. And I'm planning on writing the code for that as well. So what I do over here is I make sure it is asynchronous communication is being selected. When we have the 38,400 bits per second is set for the UART communication. Now how do I get that number? If I open up Putty, Putty is the program for serial communication, and I can check out my STM32 configuration that I have loaded earlier. Is connected to COM6. You can check out for your device where this COM6 is actually your ST-Link communication line, and you can choose your speed safely as 38,400 for UART communication. And just click on yes. You don't have to open it right now. You can cancel that out right now, and make sure you generate the code that is associated with those settings where you have a USART. You have PC13 is connected to your interrupt. Your PA5 is connected to your output, and make sure that you have the serial debugging line is also set in the SYS part. So you have serial connection is also set up for debugging. Now what I do, I just generate the code, make sure that it is generated for you, and it generates all those codes in the main file, and also the other files are being affected as a result of that. And I'll show you a couple files that are extremely important. So when you go into your project over here and look at your core part, underneath SRC you will see plenty of files here, but one of them is in particularly very important, which is the IT.C, which includes some interrupt service routines that you might possibly need in your code. And one of them is the one that has just been generated, the EXT1510 IRQ handler. So what you have to do is there's another file procedure is being called, which is HAL GPIO XI. That's in a different file, which is it's a HAL procedure that resides underneath the other HAL code. And when you click F3 at this point to check out where this procedure is, it just goes to that part, which is HAL GPIO.C, which is underneath, actually, your somewhere underneath your STM32 HAL driver sources. Okay, somewhere around here. So it's right there, as you see here. it just goes into that location, and from here it actually calls another callback function. If you have actually activated that GPIO pin, it just calls a callback function, and then that callback function is actually here. Let's check it out by pressing F3 again. It's actually right here. However, it doesn't have anything inside, and it's not recommended to modify your code over here, as this is defined as a weak procedure. Weak procedures actually don't get activated, and they're only activated if you don't have anything else. So what you do over here is you have to copy this part over here and put this into your own code. So what you do is you just copy this part, weak part. You don't delete this, you just keep it as is. And what you do is you come back to your own main program, you come down here into a part where you can actually squeeze in that information underneath. That might be a good place to write, for instance, user code begin for is one place to put that. So let me just go into that part and then Control V, my code. So what I'm going to be writing here is what I want to do with when I press the button. That might be a bit flip on the LED. So what I can do is I can just type in here how, for instance, GPIO probably what I want to do is I want to toggle here that pin, of GPIO that is residing in A, GPIO pin number 5, or I can just call it LED pin. Okay, so that's much better to name it LED pin. LED is the naming that we have given to our pin, so you can just safely put it as LED pin. Now you're fine. Actually, what I would recommend you guys to do is make sure that the pin, the interrupt that you have received is actually from that port. So what you do is you can just check if your GPIO pin is equal to the button pin that has been pressed. So you make sure that you're coming in here due to a GPIO pin press. Alright, so you come back here, and that's probably what you want to do. That's all you want to do when you execute this code. If you have a button press, you toggle the pin, and what you can also do is you can give a delay here if you want to do multiple blinks. Probably you can do, but I just want to toggle at this moment, so when I press it's just going to toggle, so that's fine with me. What else do I want to do? I want to transmit some messages here, so I can use, since I have a UART already defined to be displayed at the output, I can do halt UART transmit a message such as from my UART number 2. Okay, so that's right there, and that's going to be when I pressed the button. So I need these kind of actually definitions to be made at the top. So I need to find the number of characters, written here as, for instance, 27 characters or 30 characters, whatever, and the timeout I can give is like 10. It's a decent amount of time. And once I'm done with that, I need to complete some more stuff for the initializations for these parameters that I haven't done yet. Okay, now when I come back to the beginning of my code, I already see that the UART for UART2 has been already defined for me. so that's already there. There are some initializations for my UART already there. So what I need to add is the thing that I want to display on the screen. So what I can do is I can just use this pressed button declaration. I can put this underneath here. It's a good place probably to place that. So I can just say press button, you press the button. So that's it. I can just place a backslash n to go to the next line. So I just want to make sure that I press the button. That was a 1, I guess, in my procedure. So it's a press button 1 is my press button. So when I press a press button is going to be placed on the output screen. So whenever I do that, it's going to be placed out on the output screen. Let me check if I need to do anything else over here. If I'm missing anything else in my code. So everything seems fine. So let's just give it a shot. And let's see if it works. I don't have anything else underneath while 1. So while 1 in my main code is going to stay at its place right there. So that is completely empty. I don't do anything else inside there. I don't need to do anything. I just wait in there. So I just save my files and start up my project by building it. Check out the console outputs if I have any errors, messages, anything like that. Hopefully not. So no warnings, no errors. I just finished the compilation process. Just want to make sure debug configuration is already set. Come back up here, check out the debugging options if I have anything to add. In the debugger. So check out other options. In this part I make sure that the debugger is ST-Link as I would expect. I would expect the serial number to be there, so if I'm connected I would see a serial number here, so I make sure that the serial number is placed in here. Right there. Alright, connect under reset is a good option for reset behavior. I just place, I just say close this part and then save this part and run my code. Alright. So I see my code running, and this code running, I wait until the code is downloaded onto my device, and every time I give an interrupt with this, I just have the LED being turned on and off. Okay. So let me also show you that if I can. On the LED, I can just blink that LED by just pulling the signal high or low. Just make sure that your LED is blinking with every push button. Okay, so that's about it. Good luck with your own trial, and make sure that your code hopefully your code runs fine. We will be designing a different version of this code from a different perspective through Kyle. That's going to be hopefully not involve any HAL libraries. So we'll try to write things from scratch in that part. So until then, See you later. Bye bye.